Hello students, today we'll start a new chapter, chapter 5, and this is the first topic of your chapter 5, which is Introduction to Shock Waves. So now we'll try to understand what are shock waves. So the definition says whenever a stream of traffic flowing under certain stream conditions. So certain stream conditions means uh, about speed of that stream, speed, density, and flow, and temperature and pressure as well. So these are the certain stream conditions of any stream. So suppose we have two streams at least. One has different stream conditions which will meet with another stream which is flowing under different conditions, which means these parameters, which is speed, density, flow, temperature, pressure, these parameters will be different, right? So when one stream of different stream conditions will meet with different another stream of different stream conditions, then a shock wave is produced. Like here in this diagram, we can see that this is one stream, right? And this is another stream. So let me mark it that this is one stream before this line, and after this line this is another stream with different stream condition. Here U is the speed, K is the density, and Q is the flow, right? So here UA, KA, QB, and here UB, KB, QB. So because of different stream conditions, this will be the meeting line of two streams, right? This line. So at this line, shock waves will produce, right? So we'll consider this wave as shock wave 1 because this is the first line where two different uh, conditions are meeting. Now here, this is another, this is second stream, this is third stream or another stream. So this will be the meeting line, next meeting line. So we'll say shock wave 2. Now with this stream and this stream, when they'll meet, we'll get shockwave 4. Here with this stream and this stream, uh, we have shockwave 3. Shockwave 5 will be between this and this, right? So what we have understood that shockwaves are produced at the meeting line or meeting point of two streams with different stream conditions, basically speed, density, and flow. So the shock wave is basically the movement of the point that demarcates the two stream conditions. Now what is demarcation? Demarcation is the same thing, the line which shows the separation. So this is nothing but demarcation, right? This is the demarcation between this stream and this stream. So the shock wave is basically the movement of the point that demarcates the two stream conditions. Now the rate at which this demarcation point moves, right? This demarcation point or line moves, there will be a particular velocity of this demarcation, and that velocity is known as velocity or speed of shock waves, right? Now, let's see little more about shock waves. When a wave moves faster than the local speed of sound in a fluid, and we know that how much is the local speed of sound? It is a shock wave. So when wave moves faster than the speed of sound in a fluid, those waves are also known as shock waves. Like an ordinary wave, a shock wave carries energy. So as we know that each wave carries energy from one place to another, that is what the definition of wave. So like any ordinary wave, shock waves also carry energy and can propagate through a medium. As we know that waves, especially like because we are comparing them with sound waves, and sound waves are longitudinal waves, and longitudinal waves require medium to travel. So shock waves also require medium to travel. However, it is characterized by an abrupt, nearly discontinuous change in pressure, temperature, and density of the medium. So we have already discussed about speed, density, and flow. Here, two more things, pressure and temperature. So abrupt change in temperature and pressure will also be there. So other than U, K and Q, which is speed, density and flow, uh, these parameters are changing abruptly after the demarcation. Other than these three, temperature and pressure will also change. So these are the few parameters we need to keep in mind. So yeah, this was little more information about shock waves. And the next thing is shock waves are also produced if the aircraft moves faster than the speed of sound. Now, how much is the speed of sound? Speed of sound in air is 343 meters per second approximately. It depends on temperature. So that is the approximate value of speed of sound. And if shock waves, so shock waves are also produced if the aircraft moves faster than the speed of sound, right? So this is one more point about shock waves. If a moving source of sound waves, if a moving source of sound moves faster than sound, here our source is aircraft. Aircraft is our moving source here, and if it moves faster than sound, the source will always be ahead of the waves that it produces. So this was little more about shock waves and how they are produced. Shock waves are produced when a stream of traffic flowing under certain stream conditions, and we have taken three conditions: speed, density and flow, meets another stream flowing under different conditions. So what are those conditions again? Same three conditions: speed, density and flow. A shock wave is produced. So where it is produced? Here, when these parameters or conditions change abruptly. So here shock waves are produced. And so we have discussed what are shock waves, how they are produced, and how can we find out or about speed of shock waves. So at which speed, by which speed shock waves travel in the medium, because each wave should have some velocity or speed. So what is speed of shock waves? And shock waves we can compare with longitudinal waves like sound, so they require medium to travel. So this is a little information about shock waves. There are different kinds of shock waves. We'll talk about kinds later, depending on the requirement of our syllabus. So this is all about shock waves. Thank you.